Imagine a time when pharaohs ruled and one of the world's most iconic structures was yet to grace the skyline. Welcome to the era of the Great Pyramid of Giza. Towering over the desert sands, the Great Pyramid stands as a testament to the ingenuity and ambition of the ancient Egyptians. It's a marvel of architectural prowess that has stood the test of time, remaining largely intact for over 4,000 years. This colossal monument, the oldest and largest of the three pyramids in the Giza Pyramid Complex, was built during the reign of Pharaoh Khufu, also known as Cheops, around 2580 to 2560 BC. It was a time when Egypt was one of the most powerful and advanced civilizations in the world. The Great Pyramid was an architectural feat unparalleled in its time. Its grandeur and precision were so astounding that it was recognized as one of the 7 wonders of the ancient world, a status it still holds today as the only one of the 7 still largely intact. But the pyramid is more than just a stunning monument. It is a symbol of the ancient Egyptians' deep spiritual beliefs, their understanding of the universe, and their desire for immortality. To them, the pyramid was a stairway to the stars, a means for the pharaoh's soul to ascend to the heavens and join the gods. Yet despite centuries of study and exploration, the Great Pyramid continues to guard many of its secrets. Archaeologists, historians, and mathematicians alike are still captivated by its mysteries. How was it built with such precision? What purpose do its complex internal chambers serve? And what can it tell us about the people who built it and the pharaoh it was built for? Today we're going to dive into these questions and more, exploring the fascinating numerical facts that help us understand the true size, significance, and enduring mystery of the Great Pyramid of Giza. So buckle up and get ready for a journey back in time to the era of pharaohs and pyramids. This monumental structure still holds many secrets, some of which we will explore today. To truly appreciate the grandeur of the Great Pyramid, let's delve into the numbers. The pyramid is constructed on an almost perfect square base, each side measuring around 750 feet long. That's about 2.5 football fields laid end to end. The pyramid's original height was 481 feet. That's equivalent to a modern 48-story building and was the tallest man-made structure on Earth for over 3,800 years. Imagine that. Now let's talk about its weight. The Great Pyramid was originally estimated to weigh around 6 million tons. That's about the same as 1,000 Eiffel Towers. The volume of the pyramid is approximately 91 million cubic feet. To put that into perspective, you could fit more than 27,000 double-decker buses inside it. Its base area covers about 13 acres, which is roughly 10 football fields. This grandeur is a testament to the incredible craftsmanship of the ancient Egyptians. The pyramid's 4 sides are almost perfectly aligned with the cardinal points of the compass. The north side is only about 3/60ths of a degree off true north, which is a level of precision we would struggle to achieve even with today's technology. It is also interesting to note that each of the pyramid's 4 sides is slightly concave. This subtle curve was likely intentional and enhances the pyramid's optical impression of symmetry. The pyramid's slope angle, also known as the pyramid's angle, is approximately 51 degrees and 50 minutes. This precise angle was chosen to ensure the pyramid's stability and longevity. While these numbers are mind-boggling, they only begin to hint at the level of sophistication and understanding of mathematics, geometry, and astronomy possessed by the ancient Egyptians. The Great Pyramid is not just a monument, it's a testament to human ingenuity and the enduring quest for knowledge. The sheer size of the Great Pyramid is awe-inspiring, isn't it? Building such a colossal structure was no small feat. It took more than a dash of determination, a pinch of ingenuity, and an unfathomable amount of man-hours. So how did the ancient Egyptians manage to construct the Great Pyramid of Giza? Well, let's delve into the construction timeline to get a better grip on this monumental task. The Great Pyramid's construction is believed to have spanned over a period of 20 years. Yes, you heard it right, 2 decades. That's equivalent to the time it would take to watch your favorite 2-hour movie about 10,500 times. Quite a feat, isn't it? Now let's talk about the workforce. Historians estimate that the construction involved a labor force of approximately 20,000 to 30,000 workers. To put that into perspective, imagine the entire population of a small city, all working together on a single project. And this wasn't just a 9-to-5 job. Under the scorching Egyptian sun, these workers tirelessly toiled away to create this architectural marvel. So what was a day's work like for these ancient builders? Well, It's estimated that these workers could move approximately 1,433 blocks each day. That's roughly 1 block every 2 minutes. Think about that the next time you're struggling to move your coffee table. And the monumental task wasn't just about brute strength. It also required exceptional planning and coordination. After all, they didn't have the luxury of cranes or modern machinery. Every stone had to be precisely cut, transported, and placed. This mammoth task was accomplished through sheer human strength, rudimentary tools, and ingenious methods that still baffle historians and engineers today. In the end, the Great Pyramid stood as a testament to the determination, skill, and ingenuity of the ancient Egyptians, a marvel of human achievement that has stood the test of time. The efforts of the ancient Egyptians were truly monumental, much like the pyramid itself.
The Great Pyramid is not only remarkable due to its size, but also its precise alignment and mathematical accuracy. Let's delve into the precision of the pyramid's construction. You might have heard that the Great Pyramid of Giza aligns almost perfectly with the cardinal directions, north, south, east, and west. This is no small feat, considering the pyramid was built 4,500 years ago. To put this into perspective, the north-south axis is aligned to within 3/60ths of a degree of true north. Now that's precision, but it doesn't stop there. The builders of the Great Pyramid also displayed an advanced understanding of geometry. Each side of the pyramid was built to be almost exactly equal in length, with the difference between the longest and shortest side being less than 2 inches. This level of accuracy is astounding, especially if you consider the tools available at the time. And if we look at the interior of the pyramid, the precision continues. The Great Gallery, a grand corridor leading to the king's chamber, was built with an astonishing level of accuracy. The sides of the gallery slope upwards at an angle of precisely 26 degrees, and this angle is maintained consistently over a length of about 150 feet. The king's chamber itself, located at the heart of the pyramid, is a perfect rectangle, with the ratio of its length to its width being exactly 2:1. The chamber was constructed with such precision that it's said to be more accurate than the work of many modern builders. Finally, let's talk about the pyramid's outer casing. The casing stones were cut so precisely that they fit together seamlessly, with gaps between the stones measuring less than 1/50th of an inch. This precision ensured that the pyramid's gleaming limestone exterior remained intact for centuries. This precision adds another layer to the pyramid's mystery, doesn't it? Building materials are the backbone of any structure, and the Great Pyramid is no exception. The main material used in its construction was limestone, a naturally abundant rock in the region surrounding Giza. It's estimated that a staggering 2.5 million blocks of limestone, each weighing an average of 2.5 tons, were painstakingly cut, transported, and assembled to form the pyramid. But it wasn't just any limestone. The builders selected 2 types: softer, local limestone for the bulk of the structure, and harder, fine white limestone for the outer casing. This choice wasn't arbitrary. The hard white limestone, sourced from Tura, a place miles away from Giza, was more resistant to erosion and gave the pyramid a gleaming, polished appearance. Now let's put those figures in a modern context. Imagine building a 40-story skyscraper using only hand tools and manpower, without the help of any modern machinery. Then, multiply that effort by 20. That's the equivalent of the task faced by the pyramid builders. And it wasn't just limestone. The builders also used large quantities of granite, shipped from Aswan, some 500 miles south of Giza. This granite was used in the construction of the pyramid's inner chambers. Again, the choice was strategic. Granite, being harder and denser than limestone, provided the necessary strength and durability for these critical structural elements. In terms of modern equivalents, think of the limestone as the bricks and concrete used in today's construction, while the granite is akin to the steel beams that provide the backbone of a skyscraper. The sheer quantity and type of materials used in the Great Pyramid's construction are a testament to the extraordinary planning, organization, and workmanship of the ancient Egyptians. They sourced materials from far and wide, overcoming geographical and logistical challenges that would be daunting even by today's standards. The choice and use of materials speak volumes about the ingenuity of its builders. The Great Pyramid's architectural features are a testament to the mathematical prowess of the ancient Egyptians. Let's delve into the architectural marvel that the Great Pyramid truly is. The ancient Egyptians designed the pyramid with a series of chambers and passages, each with its own significance. The king's chamber, the queen's chamber, and the subterranean chamber are all part of the intricate layout. These chambers, coupled with the grand gallery and the ascending and descending passageways, form a labyrinth within the pyramid. The pyramid's sides are a marvel themselves. They rise at an angle of approximately 51 degrees and 50 minutes. This precise angle allows the pyramid to have smooth, flat sides rising to a perfect point at the top. The precision with which this angle is maintained across all four sides is a testament to the ancient Egyptians' architectural genius. The arrangement of the stones is another architectural feature worth noting. The pyramid's core was built using large blocks of local limestone, while the outer casing was made from polished white limestone. This casing caused the pyramid to sparkle in the sun, making it a dazzling sight to behold. Unfortunately, most of these casing stones have been removed over time, but a few still remain near the pyramid's base, giving us a glimpse of its former glory. Furthermore, the pyramid's orientation is no accident. It is aligned to the true north more accurately than our modern-day meridian building. This alignment, experts believe, was significant in ancient Egyptian cosmology, connecting the pharaoh's afterlife journey with the celestial bodies. The Great Pyramid also incorporates a series of shafts, known as star shafts, that extend from the king's and queen's chambers towards the outside. These shafts are believed to be ritualistic in nature, allowing the pharaoh's soul to ascend to the heavens. In conclusion, the Great Pyramid's architectural features are not just a display of mathematical and engineering skill, they also provide a glimpse into the profound spiritual and cosmological beliefs of the ancient Egyptians. These features make the Great Pyramid a unique feat of ancient engineering. The Great Pyramid was more than just a tomb, it played a significant role in ancient Egyptian society. As we delve deeper into the historical context of this architectural marvel, it's important to note that the Great Pyramid served as a sort of spiritual compass for the ancient Egyptians. It was built as the eternal resting place for the pharaoh Khufu, also known as Cheops. The pyramid's construction was a demonstration of the pharaoh's divine authority and the vast resources at his disposal. The pyramid was also a tangible representation of the Egyptians' intricate belief system. The four sides of the pyramid were believed to symbolize the four cardinal points, aligning with the sun's path across the sky and thus representing the cycle of life and death. If we look at the numbers, the Great Pyramid was part of a larger complex that included 2 additional pyramids, 3 smaller satellite pyramids, a causeway, and temples. This vast complex served as a testament to the grandeur of the pharaoh and the civilization he ruled. The pyramid's size alone was a statement of power. With an original height of approximately 480 feet, it was the tallest man-made structure in the world for over 3,800 years. This is a testament to the engineering prowess and the organizational skills of the ancient Egyptians. Moreover, the Great Pyramid was not just a symbol of earthly power. It was also a cosmic map, a representation of the ancient Egyptians' understanding of the universe. The pyramid's alignment with the stars of Orion's belt, for instance, is evidence of their advanced knowledge of astronomy. The Great Pyramid's historical context provides a fascinating glimpse into the mindset of ancient Egyptian society. It wasn't just an impressive architectural achievement. It was a spiritual guide, a cosmic representation, and a symbol of divine power. The pyramid was a representation of the pharaoh's journey to the afterlife and his eternal power. The Great Pyramid was indeed a centerpiece of the ancient world. The Great Pyramid is shrouded in mystery, and mathematics plays a significant role in this enigma. As we delve into the mathematical mysteries of this ancient wonder, we encounter 2 key elements that have intrigued scholars for generations: pi and the golden ratio. First, let's talk about pi. In the world of mathematics, pi is a constant, a number representing the ratio of a circle's circumference to its diameter. Remarkably, if you divide the perimeter of the Great Pyramid's base by its height, you get a close approximation of 2 times pi. This extraordinary coincidence has led many to speculate that the pyramid's builders had a sophisticated understanding of this mathematical concept thousands of years before the formal discovery of pi. The golden ratio, another mathematical concept, is also linked to the Great Pyramid. The golden ratio, or phi, is approximately 1.618, and it's a number that appears frequently in nature, art, and architecture. Some researchers suggest that the dimensions of the Great Pyramid correspond closely to a perfect golden triangle, a triangle in which the ratio of the length of the base to the height is the golden ratio. This theory adds another layer to the mystery, suggesting that the pyramid's architects might have used this universal principle in their design. But why would the ancient Egyptians incorporate these mathematical concepts into the construction of the Great Pyramid? Some believe it was to mirror the cosmos, aligning the monument with celestial bodies and natural phenomena. Others suggest it was a reflection of their profound knowledge and understanding of the universe. However, these theories remain speculative. Despite the mathematical intrigue, there's no concrete evidence that the ancient Egyptians intentionally used pi or the golden ratio in the pyramid's design. It could all be a remarkable coincidence. These mathematical elements continue to fascinate and confound us today. As we unravel the secrets of the Great Pyramid, we're reminded of the enduring allure of this ancient wonder and the mysteries that still lie within its colossal stone walls.
Modern technology has given us new insights into the Great Pyramid structure. Our understanding of this ancient marvel has been significantly enhanced by recent archaeological and scientific discoveries. For instance, in the last few decades, we've seen the rise of digital archaeology, which uses advanced technology such as laser scanning, 3D modeling, and satellite imagery to gain unprecedented insights into the pyramid's structure. These tools have allowed us to map the pyramid in extraordinary detail, revealing subtle features that were previously invisible to the naked eye. One of the most groundbreaking discoveries came in 2017, when scientists used a method known as muon tomography to detect a previously unknown void within the pyramid. This large cavity, which is about the length of a Boeing 747 airplane, has yet to be explored, but it raises fascinating questions about the pyramid's internal structure and construction process. Similarly, infrared thermography, a technology that measures temperature variations, has revealed intriguing anomalies in the pyramid's temperature distribution. Some areas of the pyramid appear to be hotter than others, suggesting the presence of hidden chambers or passageways. While the exact nature of these anomalies remains a mystery, they provide tantalizing clues about the pyramid's secrets. Robotics has also played a key role in exploring the pyramid. Tiny robots equipped with cameras have been used to venture into narrow shafts that are inaccessible to humans. These robots have relayed back images and data that have shed light on the pyramid's complex interior design. These modern technologies and discoveries have not only deepened our understanding of the Great Pyramid, but also underscored how much we still have to learn. Despite thousands of years of study, the pyramid continues to guard its secrets closely, challenging us to keep pushing the boundaries of knowledge. As we look to the future, we can expect that advances in technology will continue to reveal more about this ancient wonder. From ground-penetrating radar to artificial intelligence, the tools at our disposal are becoming increasingly sophisticated, promising new discoveries and insights. Modern science continues to unravel the pyramid's enduring mysteries. With every new discovery, we gain a deeper appreciation for the ingenuity and skill of the ancient Egyptians, reminding us of the enduring power of human curiosity and innovation. The Great Pyramid, while a marvel, faces challenges due to its popularity. Each year, it draws millions of tourists from all corners of the globe, eager to marvel at this ancient architectural wonder. This influx of visitors, while crucial for Egypt's economy, poses a significant threat to the pyramid's preservation. The sheer volume of human traffic accelerates wear and tear, and the risk of vandalism is ever present. In response, efforts to preserve the Great Pyramid have been amplified. Rigorous maintenance schedules are in place and regulations have been tightened to minimize human impact. In fact, a considerable portion of the revenue generated from tourism is funneled back into preservation efforts. This is a delicate balancing act, providing access to this historical gem while ensuring its longevity for future generations. Preserving this ancient wonder is as important as understanding its mysteries. It's a testament to human achievement that deserves our respect and care. We've journeyed through the numerical world of the Great Pyramid, from its impressive dimensions, dwarfing many modern structures, to the incredible precision of its construction. The Great Pyramid stands as a testament to the mathematical genius of the ancient Egyptians. We've touched on the massive workforce and the colossal quantities of materials used, giving us a sense of the scale and the effort that went into its creation. We've delved into the intricate architectural features, revealing the pyramid's alignment with celestial bodies and its reflection of ancient beliefs.
We've pondered over mathematical mysteries and marveled at modern discoveries, all of which continue to add to the pyramid's enigma. The Great Pyramid, beyond being a historic monument, is a numeric marvel, a testament to the ingenuity of our ancestors. As we continue to explore the Great Pyramid's secrets, we are reminded of the ingenuity and mystery of the ancient world. Thank you for joining us on this journey, and remember to like, subscribe, and share.